So we're reviewing section 7.4 through 7.6 in preparation for our test. Let's take a look at number 1. It says in exercises 1 through 2, sketch the graph of the inequality. So the first thing I want to do is what? Okay, put it in y greater than or less than mx plus b. Good. So add x to both sides. We get y greater than x, and that should say minus 2. Okay, the next thing I'm going to do is create my coordinate plane here. And then I'm going to identify my y-intercept, which is -2. Good. So let's go down to, and my slope is 1. So I'm going to go up 1 over 1. So I'm going to rise and then I'm going to run. So notice that it's lining up right here. Is it a solid or a dashed line? Dashed. I know this because of this symbol here. So I'm going to leave it just like that with my little dots. And let's put some more dots here. And then I want to shade, because I am in the form of y greater than x minus 2, I can shade in this direction because y is isolated. So I know y greater, the y-axis increases in this direction towards positive infinity. Here I have 2, 2, -2. So I know I'm shading above the line. So let's go ahead and indicate that. All right, number 2 is a little bit different because this time we have x squared. So I'm going to do the same concept. I'm going to isolate y. And I'm going to get y less than or equal to -x squared plus 4. This is a parabola. Let's do a quick recap. So let's say we have y equals x squared by itself. Remember that parabola, that parent graph, 1, -1, 1. The vertex would be at 0, 0. Then we have 2 more points in this direction, and then I can start doing transformations to this. If I have y equals -x squared, I know I'm reflecting it over the x-axis. The moment I start writing plus 2, that means you move up or down in that direction. Positive, move up, negative, move down. If we have the following, -x plus 2 quantity squared, that's when we start moving it left and right, and we move it in the opposite direction. So now let's go back to the problem we've been given. So if we're looking at this problem, I know it's been reflected over the x-axis and that I shifted my graph up 4 units. So let's go ahead and indicate that. And because this is less than or equal to, I know that the parabola, it's not going to be a dashed curve, but a solid curve, right? So let's go ahead and create our x and y axis. So here's x, here's y, and I want to go up to 4. 1, 2, 3, 4. That's where my vertex is. So let's go ahead and put our vertex there. And I know it's opening down, so I'm going to go in this direction. Remember the points that were at 1, 1 and -1, -1, those moved up 4 units, but then you reflect them over, right? Okay, when you do that, it's going to bring them on this direction. Another thing you could do is identify your x-intercepts. Let y equal 0, x, you're going to get plus minus 2. So that's actually what I want to graph. Solid line. And because y is isolated, we can shade in that direction. Y less than, y decreases in this direction towards negative infinity. So I know I'm shading on the inside of this parabola. Another thing you could do is test a point. If 0, 0 is not on the actual curve or the line or the circle, whatever it is that we're graphing, that's the point you want to test. So I'm going to put in 0 here, 0 here. Is 0 less than 4? Yes. The true side is what gets shaded. All right, let's take a look at number 3 here. We also have another parabola. I'm going to go ahead and I'm going to isolate y. This time I have y greater. Notice that it's not greater than or equal to, so that's how I know it's going to be a dashed curve, right? And I get 2x squared plus 3. Based on what I just reviewed with you guys, this parabola moved how? Up 3. Good. I know it opens up because this is positive, but it's been vertically stretched by a factor of 2. Okay, so let's go ahead and graph that and see what it looks like. So that's my x-axis, my y-axis. I'm going to label up to 3. 1, 2, 3. That says 3. Doesn't look like a 3. And then we're going to be at 5 because we're going to stretch to a factor of 2. Let's go put that, let's indicate our quantities here. And remember, our vertex was at 0, 0, but we moved it up 3 units, so now we're at 3. The point that we had at 1, 1, that was right here, we also moved that up 3 units, but then we're multiplying it by 2. So when I do that, it's going to stretch it up. So think about substituting 1 in here, you get 2, right? Plus 3, I know I'm at 5. So that's what you're doing. Okay, so we're plotting the point 1, 5. And there's y-axis symmetry, so I can do -1, 5, or think about substituting -1 into x. Solid curve, and now we want to either test a point into the given, or because I isolated y, I want to go ahead and shade in that direction. Y is greater, so y is greater in the inside of this parabola here. So that's what should be shaded in the inside. I apologize, it's a dashed parabola. Again, because we have y greater than, not equal to. Alright, so here's number 4. And I know I have what kind of graph? It's a circle. Good. I know that because I have x minus 2 quantity squared, y plus 4 quantity squared, and then I have, this is going to help me identify my radius. So my center is contingent upon these two things. Remember, the standard form is x minus h quantity squared plus y minus k quantity squared. So my center, remember, opposite signs to whatever's going on there. So my center is at 2, -4. I'm going to take the square root of this, and that's going to help me identify my radius, 3. So I'm going to go ahead and plot 2, -4 on my coordinate plane. So let's draw that up. And I'm going to put it about right here. So here's 2, -4, and then I'm going to draw my radius 3 units to the right, 1, 2, 3, 3 units up, 3 units to the left, and 3 units down. Is it a solid or a dashed circle? Solid. And now I want to test a point. Remember I said to test the center, so I want to substitute x. Here is 2, and -4 in for y. When I do that, this becomes 0, this becomes 0, and now I'm comparing 0 to 9. Is this a true statement? Yes, it's true, so that means I shade the center. Alright, let's look at the next section. It says in exercises 5 through 6, graph the solution set of each system of inequalities. Okay, here on number 5, I have a line, and I have a parabola. The parabola, I'm going to go ahead and isolate my y. And because the y is negative, I'm going to multiply everything by a -1. And notice that I'm switching the symbol for my inequality here. Oh, I forgot my squared. Okay, so now I know I have a line that's solid and a parabola that's dashed. So let's go ahead and graph that. So here's x, here's y, and I'm going to start with that solid line. So I'm going to go down to -5, that's my y-intercept, my slope is up 1/1, and notice that I'm extending my slope multiple times, and now I'm going to connect the dots. So y greater than the line would be everything above it. So all of this would get shaded. But because this is not the only thing that I'm graphing, I'm going to put the parabola on the graph first, and then I'm going to shade the overlapping region. Here, this parabola has moved down 2 units. So we're going to go to -2. And then remember, we started here, we're going down 2 units, so that means the points that were at 1, 1, negative 1, 1 would move also down 2 units, and that would be a dashed line. I'm estimating where those x-intercepts would be. And y less than would be everything below. So the only thing that's overlapping for the parabola and the line is the space in between. So let's go ahead and shade that. That would look like this. So this part in here would be your solution set. Alright, let's take a look at number 6. Number 6, I have 3 lines. I have one for the top where I have x plus 2y is less than or equal to 4, x is less than or equal to 3, and y is greater than or equal to negative 4. Whatever satisfies all 3 lines, that's the solution. So that's the portion that, or the region that we're going to shade. So let's start by making our x and y-axis. Alright, so the first thing I'm going to graph is this x less than or equal to 3. So I'm going to go x at 3, and I'm going to make a vertical line. And it's solid because it's less than or equal to. Less than 3 would be everything to the left. So I'm going to keep that in mind as I'm graphing everything else. And now I'm going to graph y greater than negative 4. So let's go ahead and do that. So I'm going to go to negative 4 and create a dashed line here. Greater than would be everything above. So so far the only thing that's overlapping for these 2 lines is this space in here. And now I'm going to graph my last equation. So let's make it easier for ourselves and isolate y. So subtract x, then divide by 2. So now I can see the y-intercept and I can see the slope. So I'm going to go ahead and I'm going to graph y at 2. And then my slope is down 1 over 2, down 1 over 2, down 1 over 2. I can go up 1, left 2, and I can extend that. Because it's equal to, I'm going to go ahead and connect this with a solid line. And remember, we're shading less than, so what's less than that purple line would be everything below it. So what satisfies both conditions would be the space in between. So let's go ahead and shade that. So what's true would be everything in here. Alright, let's take a look at number 7. It says find the vertices associated. Alright, find the vertices associated with the following. So we have constraints. X is greater than or equal to 0. Y is greater than or equal to 0. That implies that we're in quadrant 1. So I'm going to exaggerate everything that you see here. And I'm going to make this quadrant 1. Okay? So this line here is y equals 0, and if we're greater than that, that would be everything above it. This line here would be x equals 0. Everything that would be greater than would be to the right of it. So here's our x-axis, here's our y-axis. So now I want to graph these 2 lines. So I'm going to go ahead and I'm going to graph, let's isolate y on the top one. So I'm going to subtract x. And then we're going to go ahead and we're going to swap our signs. And we're going to get the following. Okay, so I know I have negative 8 as my y-intercept, but that's way down here. And I know the slope is up 1 over 1. So what I'm going to do is I'm going to get, where is my x-intercept? So if y is 0, x is 8. So I'm going to use my x-intercept to help me out. So 1, 2, 3, 4, 5, 6, 7, 8 here. And the slope is positive, so up 1 over 1, up 1 over 1. So that's going to be this line here. And I know it's a solid line. Okay, I might want to move it over, but that's okay. So far the only thing that's overlapping is this region in here. Now I need to graph this final line here. Let's go ahead and do that. We're going to move that x over. My y-intercept is 8 now. 1, 2, 3, 4, 5, 6, 7, 8. That's going to be here. Oh, wrong one. Here. And my slope is down 1 over 1. So, and I know it's going to be a solid line as well because of the inequality. I'm just going to do this to connect it. Did I go down 1 over 1 properly there? Greater than that line would be everything above it. So the only thing that gets shaded is this region in here, just like I said before. But the question said to find the vertices associated with the following. You only have one point of intersection with all 4 of the constraints, and that's this one here, so that's 8, 0. Let's take a look at number 8. It says a vineyard produces 2 special wines, a white wine and a red wine. A white and a red. A bottle of white wine requires 14 pounds of grape and 1 hour of processing time. A bottle of red wine requires 25 pounds of grapes and 2 hours of processing time. The vineyard has on hand 2,198 pounds of grapes and can allot 160 hours of processing time to the production of these wines. A bottle of the white wine sells for $11, while a bottle of red sells for $20. How many bottles of each type should the vineyard produce in order to maximize gross sales? So we want to identify our objective and our constraints. All right, so our objective function is always the profit. So when I look, let's start by defining what's going to be X, what's going to be Y. So let's define our white wine as X, and let's define our red wine as Y. And our objective, we can always call that Z equals. And the white is selling for $11, and the red is selling for $20. All right, so we're always going to have 2 implied constraints. You're not going to make negative bottles of white wine or negative bottles of red wine. So both of them have to be greater than or equal to 0. And then I'm also limited by the pounds. The red wine requires 25 pounds of grapes, and the white wine requires... All right, so the next thing we're going to do 14 pounds of white wine. Okay, so 14x plus 25y, and we're not exceeding 2,198. Okay, and the next thing we're limited by is the hours. So it says the white wine requires 1 hour of processing time. Here's that. And the red wine requires 2 hours of processing time. And it says, and can allot 160 hours of processing time. So we're not exceeding that. So we have X for the white plus 2Y has to be less than or equal to 160 hours. So now I'm going to go ahead and I'm going to graph my constraints here on my coordinate plane. And I'm going to determine where these graphs are intersecting, and we're going to identify our corners, and we're going to evaluate our objective function at those points of intersection. So let's go ahead and graph it. All right, so here's my coordinate plane. Remember, it's implied that X has to be greater than or equal to 0, Y has to be greater than or equal to 0, so we're only in quadrant 1. The next thing I'm going to do is I'm going to graph. All right, so these are the next 2 inequalities that I'm graphing, and let's identify the vertices so that way we can go ahead and put that on the coordinate plane. So when X is 0, I'm not writing. When X is 0, Y is 87.92. And when Y is 0, X is 157. Here, when X is 0, Y is 80. And when Y is 0, X is 160. So let's go ahead and graph those lines. So 157 and 0. It's going to be about right here. Let's zoom that in. So here's 157 we're estimating. My next one is 87.92 here. So somewhere around here. And let's go ahead and connect those lines. And then I have 080. So we'll do that in a different color. That's exactly right here. and then 160 over here to the right of the 157, 0. Now I need to figure out, okay, it's not very pretty, but I need to figure out where they're intersecting, the red line and the purple line. That's considered a corner. Okay, so when I solve the system, I want to figure out where this line and this line are intersecting. You can use substitution elimination. The answer is going to be 132 and 14. So now I can identify, again, the shaded region, this region on the inside, is the solution to the system. Where these two should be intersecting is somewhere down here. You can't really tell on my graph. It should be happening around here, 132 and 14. Not over here where it looks like it's intersecting, it's down here. So now I can go ahead and identify my corners. Here's one. Okay, that point, and I'll do that in a different color, is 0, 80. This point, 132, 14. And then we had the 157, 0. And we have 0, 0. 0, 0 is going to give us no profit, so we don't necessarily have to identify that one on the objective function. So we have 4 points because I have 4 inequalities, and that's typically what happens when you have 4 inequalities. You're going to have 4 corners. So we have 0, 0. We have 0, 80. We have 157, 0. And we have 132 and 14. And we're going to go and substitute that into z equals 11x plus 20y. For 0, 0, we're going to get 0 for the profit. Then when I substitute 11 times 0 plus 20 times 80, I get 1600 for the profit. 157 times 11, I'm going to get 1727. Because I did 157 times 11, and then plus 0. And then we have 11 times 132, plus 20 times 14. And we get 1732. And this is where we're going to maximize our profit. So the optimum amount of each bottle, 132 of the white, and X was white, right? Yeah. And 14 of the red, because the red takes longer to make, so that makes sense. And our maximum gross is 1732. All right, number 9 says Eric's Carpentry manufactures 2 types of bookshelves, a basic model and a deluxe model. He needs to sell at least 20 basic models and 25 deluxe models. Due to the capacity of the warehouse, Eric can make at most 100 total bookshelves. If he makes $50 profit on the basic and $65 on the deluxe, how many should he make to maximize the profit? What is the maximum profit? Okay, so let's start by identifying again first. The first thing you want to do is identify X and Y. So let's call the basic X and let's call the deluxe Y. Clearly, you're not going to make negative bookshelves. So one of your constraints has to be X has to be greater than or equal to 0, Y has to be greater than or equal to 0. Wherever you see profit, that's your objective function. So $50 profit on basic, so Z equals 50X, plus 65Y on the deluxe model. And now let's identify the rest of our constraints. I cannot make more than 100 bookshelves, right? That's how many I'm going to make. So one of them has to be X plus Y, has to be less than or equal to 100. And then it tells us that the basic model, he needs to sell at least 20 basic models and 25 deluxe. So meaning I want to do more than 20 and more than 25, right guys? Right? Do you see that? So X has to be greater than or equal to 20. And Y has to be greater than or equal to 25. So now I just identified all of my constraints. So let's go ahead and start graphing that. I'm going to make a graph for just quadrant 1, right? Because this is implying here that we're in quadrant 1. So when we're looking at this coordinate plane here, again, we're only in quadrant 1. This is my X is greater than or equal. wrong one. X is greater than or equal to 0 in this direction, and this is y is greater than or equal to in this direction. Okay, so now I want to graph x greater than or equal to 20. So I'm going to go x at 20, and that would be this one here, solid line. Greater than is going to be everything to the right of this line. Then I'm going to go to y at 25. Let's make that in a different color. So I'm going to go halfway in here. We're going to pretend it's 25. And now everything above that, so right now we've narrowed down our overlapping region to this point here. And the last thing I need to graph is the x plus y equals 100. When x is 0, y is 100. When y is 0, x is 100. So that's going to be this region here. So let's go ahead here. And here, and I'm going to connect these points intersecting. Okay. Now I just need to determine where the intersection is here and here. This is clearly x was 20 and y is 25. So that's this intersecting point. Now here, x is still 20. Need to figure out what y is. And here, did I flip-flop it? Yeah, this is 25. Sorry, 0, 25. I need to figure out what x is. The y is 25. And here, x is 20. I need to figure out what that y is. So I'm going to just do direct substitution. Okay, again, the equation I'm manipulating is x plus y equals 100. So look over here. If x is 20, put in 20 here, you get y is 80. And I can see that here at this point. Here I have y is 25, plug in 25 for y, you're going to get 75, right? And you can't tell on my graph, but it should be happening right here. So that's why it's important to make sure you're substituting. So now I have 3 points. The region on the inside, this is the solution. The corners is what we're going to use to substitute into our objective function. So let's go ahead and do that. Let's make our table over here. So we have here, let's put the coordinates. Let's put x, y. Here we're going to put z equals 50x plus 65y. And here we're going to get our profit. So let's just put a $sign there. So one of the corners we said was 2025. Another corner we have is 2080. Another corner we have is 7525. And now I'm going to go ahead and I'm going to plug that in here. And on your test, I'm okay if you use a scientific calculator only or basic. Because number 8 or anything like number 8, the previous problem we did, you will have stuff that I want you to work out relatively quickly. So that way you have enough time. So 50 times 20 plus 65 times 25. 2,625 would be what we get here, 2,625. Then here we're going to do 20 times 50 plus 65 times 80. So 20 times 50 plus 65 times 80. We're going to get 6,200. The next one we have is 75 times 50 plus 65 times 25. And I get and I get 5,375. So here we can clearly see that our maximum profit is coming from this combination. 20 of the basic and 80 of the deluxe. So let's go ahead and answer the question below. It says optimal amount of each, so 20 of the basic and 80 of the deluxe. And maximum profit is 6,200. All right, in exercises 9 and 10, it says write the partial fraction decomposition. So the first thing I want to do is start by factoring that denominator. So let's go ahead and do that. So we have 10 over, the factors for 14 are 7 and 2, and 7 has to be negative in order to get that negative 5 in the denominator. So here's my partial fraction decomposition. So now I know that they're linear, and these are my pieces. All right, so again, these are linear factors, so therefore we put a constant over our linear factors. If these were prime quadratic, then we would put a linear expression above them. Okay, so now I want to go ahead here. We can use our shortcut method. 10 equals a times x plus 2 plus b times x minus 7. So we're going to let x equal -2, and then this term becomes 0. So when I do that, I'm going to get 10 equals b, -2 minus 7, and here I'm going to get -9. 10 equals -9, b equals -10 over 9. Okay, now I'm going to do the same thing here. If x is 7, this term becomes 0. So I'm going to let x equal 7 now. And I'm going to get 10 equals a, 7 plus 2, and I'm going to get 10 equals 9a, a equals 10 over 9. So now I'm going to back substitute it back into the top. So we're going to have 10 over 9 because that's a. Make sure you do proper substitution. This is a, this is where I put my a. Okay? Here I put x minus 7 plus b, -10 over 9 over x plus 2. And now I'm going to do a state change flip. Okay? So 10 over 9 times, put this over 1, so what I'm doing is making sense. We're flipping it. And at this point, I'm okay if you either factor out 10/9 or distribute. I like distributing. Okay, 63. So here I have minus 63 plus, or minus 10, 9x plus 18. Or you could factor out, so your solution could look like this. 10/9, and then we end up with 1 over x minus 7 minus 1 over x plus 2. So either way, I'm okay as long as it's done right. All right, let's take a look at number 11. Here when we factor, let's go ahead and factor out an x. And then we're going to get x minus 6. So we have linear factors again, a over x plus b over x minus 6. So then I end up with x plus 3 equals a, x minus 6 plus bx. So I'm going to use my shortcut method again. If x is 6, this whole term becomes 0. So I'm going to go ahead and do that. So we're going to do 6 plus 3 equals 6b. So here I get 9 equals 6b. Divide by 6 on both sides. I'm going to get, I get b equals 3/2. And then I'm going to let x equals 0, because when I do that, this term becomes 0. So if x equals 0, then I have 3 equals -6a. a equals -1/2. And now I'm going to go ahead and I'm going to substitute it again back to the top. So I have -1 over 2 over x plus 3 over 2 over x minus 6. Okay. So now I'm going to do the state change flip. If it helps you put this over 1 so you can see that a little bit better. And then I have 1 over x plus 3 over 2, 1 over x minus 6. Again, I'm okay if you factor out the common fraction or distribute it, as long as it's done right. So I end up with -1 over 2x plus 3 over 2x minus 12. Make sure you distribute to both terms.